Hi, I'm Kunal.
Hi, I'm Arjun.
Hi, I'm Anuj.
So we're going to be analyzing another representation of what another student in this class drew to represent what we learned in class. So this is a representation of what we learned on Monday. We did a lab where we used a technique called indirect measurement, which is very important for science, and I'll explain why later. But basically what we did is we took some oil and we dropped it on water. And what we were aiming to do is by doing this form a monolayer, which is basically a one molecule thick layer of oil, right? And by measuring the radius of this monolayer, which was probably like, 2 inches, right? Like around 2 inches, we could measure that with a simple ruler and using formulas that we could learn in elementary school, such as a volume formula, calculate the area of the circle, and also using this as well as the volume of the actual oil that we put into the water, calculate how thick the layer was in terms of height, which is measuring something that's on the nanoscale. So pretty cool that we could use an indirect measurement to find something with such simple tools.
Okay, so indirect measurement is using proportions and ratios to measure all things, whether they're extremely big or they're extremely small. So in this case, there's a group of construction workers right there, and what they're trying to do is they're like trying to make a building. And so what they do is they create a small model of the building, and later they use proportions to determine like the actual size of the building. And so indirect measurement is just really important to science, and scientists use it when like their tools cannot measure things of certain magnitudes because they're either too big or they're too small.
All right, so moving on to the next portion of the drawing here, we see that up in this top corner that two groups are arguing based on the color of the building that they're creating. So what this is meant to represent is constructive and destructive interference. So in waves, constructive interference is when the top and bottom of the waves all line up and they combine to create a wave of larger height or amplitude. And destructive interference is when the top and bottoms actually cancel out and they create a wave that is lower or has a smaller height than that of what it was earlier. So as we can see in this first scenario, the two groups have compromised and have created half and half based on the colors portrayed here, and they have a complete building. And in scenario 2, we can see that both groups are still arguing based on the color that they want, and they've ended with absolutely nothing, which represents how the waves detract from each other.
So this somewhat more simple representation of more complex subjects is really important in science to be able to explain to people subjects that usually require more studying to look into. But this has its limitations, and no analogy is like perfect. One way we thought we could make this one better is in regards to constructive interference. As you can see, they agreed on kind of like how they can put their own design on the final building, each of their own designs on the final building. But if a wave constructively interferes with another wave, the resulting amplitude, as he said, is the sum of those two waves. So the way that this could be shown in the picture is if the building on the left, the bottom left of the screen, was the sum of the height of each group's original plan. So that'd be able to show how the amplitude of the wave is the product of both of them.
Thank you. Are there any questions? Yes.
So you're describing constructive and destructive interference. What is that called, or what technique would you be using that uses constructive and destructive interference?
So the question was, what technique uses constructive and destructive interference?
What do you mean by like what technique? You mean like what we use to see this in real life?
Yeah. What do you use to see this, or what is this explained in real life, and what is it called? Like, what's a physical phenomenon?
Okay, so what the question was, how can we see this in real life? So you can see this in real life if this is basically diffraction, right? And that's basically any phenomena that occurs when light has to pass around an obstacle or runs into an object like a slit. So basically, because light is both a wave and a particle, you can get some interesting effects when you have things like slits. So if you can imagine like a pinhole, two pinholes on a paper, when the light goes through those pinholes, those light waves behave interestingly, and because they're waves, when they go through the pinholes and they come out, they'll both come out as their own like wave, and then when it runs into that other wave, you can see interesting patterns where certain parts will have constructive interference and certain parts will have destructive interference. And what this will look like is certain parts will be brighter and certain parts will be darker. And you can see kind of like this effect where there's like patterns of light and dark next to each other. This can also be used to measure things on the nanoscale, which is also what we did today, but it's a little bit of a more complex process. But what you can kind of see, like right now, I don't know if this is actually correct. Maybe the instructors can verify this, but certain like shading patterns under the projector screen you see there, or to the right of it, that might result from like diffraction slightly. I'm not too sure about that, but something similar to that is what you could see in real life to know if you're seeing destructive or constructive interference. Does that answer the question?
Questions from parents or students? We got a thumbs up at least. Is there any way that you think you might be able to add atomic force microscopy to this metaphor? If you've got like say you've got like the two different people, they've got two different patterns on them. Say if those patterns were not just patterns but textures, could you add AFM to this picture?
So AFM stands for atomic force microscope, and basically that uses instead of using light and electrons, it uses like feeling as its way of identification.
So if you were to like do that on the building, maybe you could add features where not only you could see them, like right now we can see the circles and stripes on it. Instead of just having those, you might be able to have like physical objects protruding from the buildings that each group wanted that were maybe smaller protrusions, like not as big as the circles. And you could have like a part of the picture which is like a zoomed in magnifying glass view of like these like protrusions and like people, I don't know, maybe sitting on them or something. Something that represents physical touching, kind of, instead of just seeing.
Yeah, or maybe if the lines were like physical, like bumped up lines, and the dots were bumped up dots. Say if you were one of those people, maybe if you were blind, you could know what floor you were on based off of what texture that part of the building was, right? So that might be another way to try to incorporate that. Any last questions? Artists, will you stand up?